Hello everybody. Ms. Shadow's here, and we're going to be looking at some new stuff, but to start off, we're going to remember what sequences are. Okay, if we look at sequences, this was back in Chapter 5, and Chapter 5 started off with different types of sequences. We had something that looked like this, like 3, 6, 9, 12, 15, etc. Right? And with this one, we looked for that common difference. How is it changing, right? So my rule for this one was plus 3 each time, and that made this an arithmetic sequence, right? We looked at these. We were able to write the equation of them, right? The equation for my sequence is going to be my common difference times n plus my 0th term, right? So in this one, my t of n would equal 3n, right? My common difference times n. Working backwards, I would have a 0, so plus 0, right? This should all be reviewed. We've looked at this many times. What we're going to look at today in more detail, though, is what if I've got something like this? What if I've got 4, 8, 16, 32, 64, etc. This one, in order to get from here to here, I add 4, but then I add 8. I'm not adding the same thing each time, right? So it's not arithmetic. It doesn't have that common difference. So instead, we're going to be looking from piece to piece to find what is my multiplier. In this case, my multiplier is going to be times 2, right? And then we're going to look at this one in some more detail in a minute. Right? You have, to start off this section, you have a worksheet that looks like this. This is not your worksheet. This is a separate example. But your problems look very similar to this one right here. So what we start off with is we start off with these figures, and we want to figure out what my fourth figure is going to look like. So, and I'll get 0 after I've gotten my fourth one. So in order to get from here I have 3, and then here I have 9, and then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3, right? So there is going to be 27, right? So to get from here to here to here to here, I have to multiply it by 3. And if I'm looking at this picture right here, my picture looks like it's just tripling in height each time. My bottom stays the same, so I'm going to have 3 across the bottom, right? So this is 3, this is 9, this is 3, this is 3, this is 3, this is 1, right? So it's just multiplying it by 3 each time. So across the bottom, I'm going to have 3, and then my height is going to be broken up into 27 pieces, right? That's actually going to be pretty darn hard to draw, right? But I'm going to do my best. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and that means that top one there is 27. I'm going to erase that so it looks a little bit more straight up there. Okay, so I've now got my figure 4. So if every time I am multiplying across, right, I'm multiplying my height by 3, in order to get my figure 0, I'm going to have to be dividing my height by 3. So I'm going to have 1/3 by 3. 1/3 times 3 gives me an area of 1. So there's a total of 1 tile here. If I'm counting up my tiles as I go, right, this is 27. 3 times 27 is 81, right? Now that I've got it in a table, I can look to see. I'm just multiplying by 3 each time, right? Just times 3, that's all that I'm doing. So then 81 times, not twines. So that's going to be 243. 243 times 3, that's 9, 12, 729. And then 729 times 3, 7, 6, 7, 8. 2,187. okay? So now that I've filled in my table, I can see my sequence, and really, once these numbers get this big, I mean, we don't really care what they are at that point. We don't need to keep going past 7. That's really, really big. So it says, what is my starting value, right? My starting value is going to be my 0th term, okay? My 0th term is always going to be where the number of tiles in figure 0, or if I just have my rule, I can work backwards, right? If I multiply by 3 to go forward, I'm going to divide by 3 to go backwards. So 3 divided by 3 gives me 1. So t of 0 is equal to 1. That's also a, and you'll see a show up here again in a minute. What is my multiplier? What am I multiplying by each time? Well, my multiplier is going to be 3. Now, up at the top of this page, they give you the general rule for this. This is how I can write this explicit formula. A times b to the n. A, that's my 0th term. That's what would come before my first term if I was making a table. And then b, that's my multiplier. So I found both of these things. Just like before, I had to find my 0th term and I had to find what my common difference was. The same idea. I found my multiplier, right? So, and I found my 0th term. So my t of n is equal to 1 times 3 to the n power. And because I just got a 1 times it, I can just rewrite it as 3 to the n. Now it says to graph this rule on the provided coordinate grid. Now if I'm looking at this, my first term is when I plug in a 1. When I get a 1, I'm up here at 3, just looking at my table, right? 1 at 3. At 2, I'm up here at 9, so there's 3, 6, 9. And then past there, it's not even going to fit on my grid, right? I'm not going to go up another 6. Instead, I'm going to go all the way up to 21, which would be way up here, right? So we'll notice these have that very steep growth. They get very big very fast. They're not linear. They are what we call exponential, and that's what we're going to be looking at these sequences to help us figure out eventually, is exponential functions. Let's look back at this example right here and see if we can write that in that t of n is equal to a times b to the n. Remember, a is my 0th term. So if I'm multiplying by 2 to go first, or to go forward, if I need to go backward, I'm going to divide by 2. So 4 divided by 2 gives me 2. That's going to be my 0th term. And then my multiplier is times 2. So I've got t to the n is equal to 2 times 2 to the n. Okay? So for today, your examples, or your worksheet follows this example almost exactly. So go ahead, work through, let me know if you have any problems, and I will see you next time. Adios.